So over the past week or so, Brady's got quite a number of emails from 60 Symbols viewers asking about a game called Portal 2. The viewers have been asking whether physicists here in Nottingham might be interested in commenting on the game because it's quite sciencey, quite physicsy. So this morning I downloaded Portal 2, which took a very long time, and I've been playing it for the last couple of hours. It's been a long time since I've played video games. A long time since I've played video games.
Wormholes are solutions to Einstein's equations. In 1915, Einstein developed his theory of general relativity, in which he was able to show how space-time could be curved by the influence of matter, and that the curvature of the space-time told the matter where to move. And it's used every day. General relativity is used to explain things like the orbits of planets around the sun.
In fact, what I found is that as a complete newbie to this, I got overwhelmed, I must admit, by the plot, because it's Portal 2, so it's a sequel to Portal. But in a nutshell, what you're a character called Shell. You've woken up in a scientific complex, a megalomaniac computer, effectively called GLaDOS, which is a portal gun. And the portal gun is the most important aspect of this entire game, and hence the name Portal. In that, it allows you to blast, effectively, portals, wormholes in space-time.
And the wormhole is a solution which allows you to connect one part of space-time to another part of space-time, simply through the curvature of the space. It's been put forward in science fiction as a way of transporting vast distances across the universe.
There are interesting sciencey concepts in here. The wormhole idea, first of all, that's a staple of science fiction. It's something that very many scientists, physicists, particle physicists, cosmologists have looked at very seriously in terms of, can we create wormholes in space and time? Perhaps not in this context. They've really thought about traversing very large distances, light years. In this case, it's over much smaller distances, but the overall concept is the same, is that you're sort of moving through space and time through a completely different route than is usual.
They are, we don't know if they exist. They are solutions. They could in principle exist. The first one was actually discovered by Einstein, I think, in Einstein and Rosen in 1935. It's called the Einstein-Rosen bridge, that linked two regions of space-time together. But as an example of the problems they face, they're very unstable. And so in the 1960s, another megastar of general relativity, John Wheeler, demonstrated that that solution of Einstein's was actually unstable. So as soon as the bridge formed, connecting these regions, it would pinch off again, so that a light ray couldn't propagate through from one end to the other before the bridge collapsed.
So for a physicist, I guess what's most exciting about this game is that you've got these wormholes that you can place in different locations, allow you to solve different types of puzzles, to move from space to space in a very novel way, which after a while gets quite intuitive. And the reason so many 60 Symbols viewers are interested in this is because I guess they're interested, well, is this type of thing possible? Could we actually do this?
And another megastar of general relativity, Kip Thorne, along with Morris, came up with the conditions that you need. And basically what you have to do is this bridge that forms, this tube, if you like, that connects the two regions, this has to be stable against collapsing. And the way you have to do it, it turns out you have to have some form of very exotic matter. And it's got negative energy, effectively, or negative mass. So this is like having particles with a negative mass. We don't know such particles.
Now, I'm not a particle physicist, I'm not a cosmologist. I'll get the disclaimers out of the way first of all. But from my reading and my understanding of wormholes, you need huge amounts of energy to actually create these type of things. We're not talking about, sort of, levels of terrestrial energy. We're talking about the energy of billions and billions and billions of stars to actually be able to warp space-time in this fashion, so you can move through space-time like this. So this is not going to happen. But again, as a thought experiment, as an interesting way of looking at some unique physics or strange physics in a different environment, this is really interesting for a physicist.
But the general idea is you have to do something a bit unusual in order for them to exist. And then you, in principle, a particle could traverse from one region to another. But that opens another problem, potential problem. And that is, because it's linking space-time, these wormholes could either connect one spatial region to another spatial region, or it could connect one time to another time. And it opens up the possibility of time travel, okay, which is, how exciting is that? But in particular, it opens up the possibility of going back in time. And then you have all these paradoxes which emerge. As soon as you have these possible scenarios where you can go back in time, you could go through a wormhole, re-enter a minute before you went through and shoot yourself. And then how have you managed to shoot yourself? Because you don't exist. And these are paradoxes, and Hawking and Thorne and many people think general relativity can't allow for these. And in fact, Hawking has a chronology protection conjecture. Hawking's idea of how this affects wormholes is quite neat. It's a feedback mechanism, he said. So this will prevent the wormholes from actually allowing this to happen. But it could also be the demise of the wormhole. So that's why I'm telling you. And the analogy is a nice one with sound. So when you go to a rock concert, you often you hear the speakers go berserk, and there's a feedback loop. So what's happened is the sound has gone through the microphone, maybe from the singer, gone down the wire, been amplified, come out of the speaker, and as long as it goes out into the auditorium, you're okay. But if some of that sound gets back into the microphone, and then it goes through the cycle again, it gets amplified, it gets louder, then it goes back through, and that's a feedback loop, and that's what leads to the horrendous screeching, and of course you then can't hear what's going on. And Hawking has said that a similar thing will happen in wormholes. For wormholes to be of any use in the sense of being able to travel through time, it's got to at least be able to have light through it or particles going through it. So it has to be a reasonable size. But as soon as it becomes a reasonable size, then it can allow radiation to go through it. And once that radiation goes through it, in fact, it can create quantum fluctuations, can create more and more radiation, virtual particles. You'll get this cascade. The radiation comes through and gets amplified, going through and through and through, and eventually will cause the wormhole to collapse or explode and disappear. So Hawking actually thinks that wormholes may not survive because of this, and there's a great debate going on as to whether they can or they can't.
So with many of these games, and particularly Portal 2, well, the computer has to do the calculations, and it has to take the laws of physics and the equations of physics, and it has to solve them. And what it's doing is basically solving what we call differential equations. Now, I don't want the entire viewership of 60 Symbols to switch off the moment I say the differential equations. Differential equation, the simplest possible differential equation. You're probably going to cut this out, Brady, but I need to get a marker.
I don't think people are actively looking for wormholes. What people have done have simulated what something would look like if you were looking at them through a wormhole. So if we stumbled across a wormhole and that wormhole was connecting us to some different part of the universe, then the light gets all bent and distorted as it goes through these large gravitational fields, and people have simulated that because they are just solutions to Einstein's equations. So one of the beauties of Einstein's equations is once you've got this solution there, then you can do things like you can propagate light through it, and you can say, well, what happens to light? And you can be at the other end, and you can and simulate what you would detect.
What did you detect? What does it look like?
It just looks like a mess to me.
Equations that embed the reality of the physics mean that translates to the computer game and it feels real to you. But it's mathematics, it's mathematical physics. And we tend to avoid maths in 60 Symbols, and Brady and I have talked about this quite a lot. This will probably get cut, but...
I've never heard of Portal till you mentioned it to me. Never mind Portal 2. No, I'd never heard of Portal. I'd better go and find out what it's about.
This is me. I'm walking around. This is a character Chell in the game. I'm moving back and forth. I'm pressing this key down. Now the computer is making those calculations on the basis of when I hold this key down, what's the displacement, what's the speed, etc., and then calculating that and updating the graphics accordingly. When we do something like this, something really neat like this, then you can see the gun recoils. The gun comes back, it recoils, conservation of momentum. There's, to make that look real, you have to have the physics and you have to have the maths underneath the physics, and you have to code that to make that all look real. Neither the makers nor the distributors of Portal 2 have paid us any sponsorship for this. I did this in my own time. I did not waste university resources. I'm a physicist. I know nothing about cancer research, so no cancer research has been hindered by my playing of this game.